Hello, my name is Stephen Wade. I'm a student at the Full Sail University in the Computer Animation Bachelor Degree program. Today I'm doing an experiment in physics, and I'm trying to see if electrical current will produce heat. To do that, I'm going to need to create a circuit, and I'm going to need a power source. I'm going to use a 1.5 volt D battery. I'm going to use a strip of tinfoil which I've shaped into a wire. And because I'm measuring the temperature, I'm going to need a digital thermometer. And first I want to take the temperature of the wire before I add the electrical current, and then I will record that. And I'm at 82 degrees. So now I will create the current by connecting the negative and the positive ends of the battery together with the wire. Now what's happening is the negative end has too many electrons, and it's going to try to get rid of those extra electrons by putting them into the conductor. Now the positive end can receive those extra electrons, so it's going to travel all the way around. Each atom is going to send its extra electron into the next atom, and so forth all the way around. And it's going to create a circuit. So we know that there's energy involved here. We can already feel it's getting hot, and it's at 94 degrees currently. So I'll go ahead and stop it at 94. Or actually it went up to 95. So we'll record 95. So we had a difference of 13 degrees. Now, we know that we already figured out that there's energy involved in the electrical current, but how does that get transferred into the heat? I'll relate it very quickly to friction. If we had a circular track with a ball on that track, and there's an amount of energy added to the ball so that it would roll around the track, eventually that ball would stop. Now that's due to the force of friction acting upon the ball. But there was no energy loss. The energy went somewhere. It was transferred in the form of thermal energy. A similar thing happens with the electrical current, except for it's not friction that causes the thermal heat. It is the resistance of the conductor, or the resistance of the circuit. So in our case, we have a battery, and we have a positive end and a negative end. And so as the current travels through, the conductor is going to receive some of that energy, and it's going to basically absorb it. And it's going to absorb it in the form of thermal energy. So not all the energy is being circulated around. Some of it is staying in the conductor, and it's getting hotter. If there was a light bulb added to here, then that light bulb, the heat would light that bulb up, and then the current would come back into the battery slower. But because there's not enough resistance, the energy is going to keep traveling through, and this battery will burn out very quickly. So to sum it up, basically, the thermal energy comes from the energy that is absorbed in the conductor. And tinfoil has a higher resistance than copper or silver or gold. That's why we use copper in most of our electronics. So that is all for today. Thank you very much.